volumes accordingly. So here we are done with the module that is related to containerization. I have shown you the demonstrations as well. So it's time for us to continue with the learning path 6, in which we will going to deep dive into the implement user authentication and authorization. This is very important topic to be discussed because security plays a very important role in our life, digital world or real world. Because we don't want any unauthenticated user to access my resources. So I want that a person who is trying to access my resources, first of all, I should know him, and then he should have appropriate permission to do so. So authentication and authorization plays a very important role. Now we need to understand how Azure will authenticate a user and authorize a user. So we're going to explore the Microsoft Identity Platform, implement authentication by using Microsoft Authentication Library. Means developers can use this library, this SDK, to communicate with Azure to provide the authenticity and authorization. And last, which is all about shared access signature. Mostly we'll use it with services like storage account and so. So I'll talk about these 3 points. We have left with an hour in which we have to discuss this, including the practical. So explore the Microsoft Identity Platform is the very first topic. So Microsoft Identity Platform for developer is a set of tools that includes authentication services, open source libraries, and application management tool. So after completing this particular topic, you will be able to identify the components of the Microsoft Identity Platform. We will also get to know 3 types of service principles and how they relate to application objects, and how permissions and user consents operate, and how conditional access impact your applications. Now, let's look into this diagram. When Azure was launched, it was using Azure AD for Developer version 1.0 for authentication. Means at that time, any resource which is integrated or which is hosted in Azure, if it wants to access Azure resources, then it has to prove its authenticity, which is stored in Azure Active Directory. Means in Azure, we have only one way to authenticate a user, that is with the help of Azure Active Directory, right? So user must be a part of Azure Active Directory if that user want to access any resources of the cloud. But in today's world, it is not like that. In today's world, you have seen it in most of the application, you can authenticate a user by various means. User can authenticate by the Facebook, Google, Gmail, Twitter, right, or their personal accounts. So how it works? So now Microsoft Azure says that we can also work with Microsoft Identity Platform version 2. It is a new way of performing authentication. When you are going with the Identity Platform version 2, you can authenticate your users not only from Azure Active Directory, but also with a personal account, social accounts, or local accounts. So you have wide variety of ways to authenticate and authorize your users. Now, Identity Platform version 2 has inbuilt capability to work with the Azure AD account, which the old platform was providing it to you. Now, if the Identity Platform version 2 is giving you the old support, right? So why we are explicitly managing the Azure AD for developers as well? Why not we just go out and get rid of it? Because sometimes we create an application which only wants to authenticate it from Azure AD, and in future they don't want to change this behavior. So why to give some extra complicated features to them? So in that case, we use a specific library that is called ADAL, Azure AD Authentication Library, that will allow users to work with Active Directory only. But suppose I created an application today which is authenticating your user from AD, but in future you might want to authenticate a user from personal Microsoft accounts, social media accounts, local accounts. So you want to keep that scope in your application. So in that case, you should use Microsoft Identity Platform version 2. And as a developer, you will use Microsoft Authentication Library, that MSAL. It is a SDK to work with Identity Platform version 2. And IDAL is a library that is used to work with a version 1, right? So this is the beauty of it. So when we are working with a browser, right, with a portal, we are using this. So you can log in with the AD or with the other sources. But as a developer, if I'm creating my application and I want to authenticate users from cloud, so I can use MSAL or ADAL. If I'm using ADAL, I'm restricted to authenticate my user from AD. But if I'm using MSAL, so I can authenticate users from different sources. So that's the target audience are. Now, if you need to explore more on that, so how it works. So once we understand that, so you need to understand the concept of service principal. So service principal basically is an identity to which permissions can be granted, right? So user is an identity to which permissions can be granted. Group is an identity to which permissions is granted. Role is an identity to which permission is granted. And service principal is also an identity to which permissions are granted. Now, how it works. So let's say this is my application, which is not running in the cloud. And this is my Azure. Now in Azure, I have so many resources. Let's say AD is there. Plus I have service 1, service 2, service 3. And from my application, I want to access service 1 and service 2. So I have to prove my authenticity. So users of my application needs to provide authenticity, right? So how to do that? So in that case, my application should send a request to Azure AD, right? And in Azure AD, the user must be registered within Azure AD, within partner's account, or maybe with social media accounts. And Azure AD will authenticate a user and give the result back to my application with the token. Hey, you are authenticated with these permissions and you can access the service. But how it happens? How this application will tell AD that which application has submitted a request for its user. So in Azure AD, we have a concept of registered app. Registered app. So we will going to create a new registration, and I call it, let's say, my app. When I created this my app, actually it will create a application object. It will going to create an application object. Application object. So for each registered app, there is one application object having its ID, application ID, or we call it client ID. Client ID. And this application object is created in a tenant. Tenant means Azure AD, right? So you can have many registered app in the tenant. So every registered app has a client ID. And then what will happen? When I'm configuring this registered app, I will define that how I want my users to be authenticated. So I can say from Azure AD, single tenant, multi-tenant, right? Multi-tenant means from my AD plus my partner's AD, right? So I'm just saying multi-tenant, or maybe social media and personal account. So I have to choose one of the option. Now this application says that I know where I have to authenticate my user. So from my application, I will submit a request to AD as a programmer, and I will say that that request will go to the tenant ID. Tenant ID is, let's say, ABC123. Within that tenancy, there is a registered app whose application ID or client ID is 1A, that is this one. Now, when request goes to that tenant, then it will say that, hey, tell me your credentials. So I will provide my username and password. So when this request will go to AD, this request will be forwarded to this registered app. Why? Because this request says that in this tenant ID, this is ABC123, right? There is a registered app with this ID, that is this one. I want to forward this username and password for that. So this username and password will be verified from the source that you have configured. And if you're valid, you will get a token back. And that token will contain the permissions to work with the resources, and you can access the resources. So this is the flow. Now, in this application, you can have maybe 100 users. 100 users are there. So each user will get its own token, right? Generated by this app. And that's what we call service principal. Service principal, right? Service principal. So how many service principals we can have? We can have many service principal depending on the number of requests, right? So one registered app, has one application object. So there is one-on-one relationship between the registered app and the application object. But there is one-to-many relationship between the registered app and the service principal. One registered app can generate multiple service principal, and then we can grant permission to them. So that's it. That's what it is trying to talk about it here. When you register an app in the portal, you choose whether it is a single tenant, whether it is a multiple tenant, or it can be authenticate a user from personal or social media accounts. And every time you create and register your app, it will create a application object, which has its own app ID and client ID. Service principal object, application, managed identity, legacy. Basically, you can say it is a token. It is an identity to which permissions can be granted. Now, there is a relationship. So there is one-on-one relationship between the software application and the registered app. And there is one-to-many relationship between the registered app and the service principal objects. Right. Now, before I get into this, I just want to show you a quick example. So here, if I go back to my Active Directory, Azure Active Directory. So in Azure Active Directory, I have the registered app registration. So here I have registered so many apps. If you want, you can click on new registration and you give it a name and how you want to how this app will authenticate a user. For accounts in the organization directory, single tenant. Accounts in your Active Directory plus partners Active Directory, that is multi-tenant. Account in any organization directory and personal Microsoft account, or just personal Microsoft account. You can specify that. And as soon as I click register, it will going to show you this entry here having a unique application ID. Now, when I submit my request, I will say that this application which I'm talking to has its own application ID or client ID, which is available in an Active Directory whose ID is this. This is the tenant ID. So I have to define the path that in which tenant, which application I would like to forward my request to. And that request will going to authenticate a user as per the specification and give you the result back. So we need to understand the permissions and the consents. Right. Now, if you need to understand the permissions, how the permissions will be granted. So applications that integrate with the Microsoft Identity Platform follows an authorization model that gives users and administrators control over how the data can be accessed. So if your application want to talk to any AWS resources, so permissions need to be granted, right? So we have two types of permissions. One is a delegated permissions and application permissions. Now you have seen that there are some applications like maybe Google, Hotmail, Gmail, where when you open that application, you have to type your username and password. So permissions are granted to the logged in user, right? That is called delegate permissions. We are delegating the permissions to the users of the applications. So each user can have a different permissions. Second type of permissions are application permissions, which applications which are not running within specific account. Any user can access that application. And if application want to access any resource, so you must grant permission to that application. Example, whenever you buy a new mobile and you download some app from the Play Store, That app says that, hey, I want to access your contact. I want to access your messages. I want to access your camera. So you are giving permissions to the application, not to the person who is using that. That is the application permissions. So you should know what your application needs and you should ask for the permission, right? When the person is installing an app, and the administrator will grant permissions. If permissions are granted, then your code will work, otherwise error will be thrown. Now, whenever you are asking permissions, so there are three ways by which consent will be given. One is static user consent. Means static means I know, right? I know what permissions I need in my application, right? So I should go with each and every single permissions and I will request for that. So at the time of installation of or creating that instance of app, the permissions will be granted. So I can get only those permissions which are listed in my requested permission set. So that is static user consent. But it is hard to know what all permissions I need. And sometimes it is a risky thing because I might ask for some permissions which might corrupt my system, right? So lot of efforts are required. So the second best option is, or the second option, which is the best one, is incremental and dynamic user consent. Means whenever I install an app, I will give the minimum permission to that app, what minimum permission that app needs. Now, whenever user submits a request, whenever user logs in and he says that, hey, I am interested in working with service X with read permission. So dynamically, you will add more permissions. Start with minimum and start granting more permissions as per the requirement. So that even not by mistake, you're not giving some extra permissions to the applications, which might be harmful. Then the last one is admin consent. Now, admin consent basically is required when your app need access to certain high privileged permissions. And admin consent ensures that administrator have some other control before authorizing an app. So whenever you are giving some admin consent, you should check that what permission your app needs and how it will going to affect your environment, right? So you should check each and every aspect of admin consent because in admin consent they might ask you, hey, I need a permission to delete some resources or create some resources, right? Which is a risk, right? So you have to be very sure about it, what you are doing. Now, this is how to ask for permission. So whenever you talk about the first one, static permission means when you are creating an app, so you will grant permission there. So in the registered app, whenever you are registering your app, you can see here there is an API permission. So you are granting all the permissions here, what your app needs. So no matter who is accessing, who is authenticated from this registered app, these permissions will be granted, right? But it is a risk because I don't want to give certain permission to certain user. So I don't need it. I want that user can ask for permission. Right. So that is the second way. So when user is submitting a request, get request, so he will use the scope parameter. In the scope parameter, he will decide what permission he needs. Like in this case, the customer is requesting or client is requesting to read the calendar's information and permission to send an email. And when he logs in, the permission admin will give consent and then permissions will be granted. So this is basically the second way, means granting permissions on incremental basis. Now, how to perform this? How to communicate with that? So I just told you that, okay, I have registered my app here, right? So my app has this client ID and it is available in this tenant. That's what I have, right? And I want that I want that my application can authenticate its users from this, and then they can ask for certain permissions. Means I'm going to show you this example scope. So how to do that? So first of all, you need to programmatically interact with the Azure AD, right? Or Identity Framework version 2. So you need to work with MSAL. So you need to install Microsoft Authentication Library into your application. And Microsoft Authentication Library can be used to provide secure APIs to Microsoft Graph, other APIs, and third-party APIs. Because with MSAL, I can submit my request to the registered app in the Azure AD, prove my authenticity, get a token with the permissions which allow me to work with Graph, other APIs, whatever I have requested for. That's what it works. And I can use this SDKs in different programming languages. So we have same SDK available for different programmers in different languages. It is not only for .NET. So every programmer, like Java person who's good in JavaScript, Java, Python, Android, iOS application development, they can use the different same SDK in different languages and work with it. And they can design the web applications, web APIs, single page applications, mobile and native applications from where they want to access these resources by requesting for permissions. Now, how to do it? You can basically use different ways to prove your authenticity. You say that, hey, I would like to authenticate from the registered app, but how? Right, right. How to do that? So in that case, you have to choose one of the strategy, right? What strategy you will going to use? That is, you can use authorization code, right? You can use client credentials. You can use on behalf of implicit device code authentication, integrated windows, username and password. That's it. Like authorization code. I created a website in which I have given a user, hey, you can authenticate user from Facebook, Google, or maybe from your, local username and password of the website, or maybe AD. So in that case, when user clicks on it, your request will go to AD and AD will authenticate. Client credentials. It is for daemons, right? Where I'm not running my code with a user account. It is running in background. And still I want to communicate with Azure services. So client credentials are there. On behalf of, let's say my application is talking to service one and service one is talking to service B, right? So service B is not aware about me. It is only aware about service one. Right. So let's say this is me, my application. It is the service one and it is service two. So I proved my authenticity with AD. I got a token back. And with that token, I submit request to service one. Right. Service one knows me. So it validates the token. But when it sends a request to service two and same token is sent. So service two says that I don't understand this person. I don't have any entry with me. This token does not have a permission to work with me. So I can't allow you to do that. So service one, before sending a request, it will send a request to AD and it says that generate me a new token on behalf of the token one. So it will get a new token, which is basically based on the exist token, and new token is sent with a request, which contains the information about a service one. So service two will check the token. It says that, oh, service one has sent it. I know about it, and I'll give you the result back. And then that result will be given back to me. So that is basically concept of on behalf of. Implicit, we can use implicit. It is basically a user-based application where user is maintaining its own username and passwords. Device code authentication is the example that I will show you. Like, you know that you have a smart TV, right? When you open a Netflix on it, let's say it says that, hey, this is the URL that you can open in your mobile and then prove your login credentials there. Once it is approved, then I will automatically get a token and I will start the Netflix on the machine, on the smart TV. Right. So that's a device code authentication. Integrated window, when your computer joins a network, your domain. So automatically, right, it will get access token so that it can access the resources of that domain. So there are different flows available that you can use. Now, programmatically, if you want to communicate with the Azure AD, right, to prove your authenticity. So there are multiple ways of doing it. So here we are talking about the first technique. After installing the Microsoft Authentication Library, I can use public client application builder. So I can use this class in any application which is running on desktop, which is running on my server, right, on my machine, right, which is not secure. So from that application, I'm sending a request to AD, right, and I say that AD that I want to forward request to the registered app, this registered app, and that registered app will give you the credentials. Oh, login page, you can type your credentials and then you will get authenticated, right? But sometimes your application is secured, which is running on a web server, right? It is a secured website. So in that case, you can use confidential client application builder. So this will tell Azure that your request is coming from the trusted source. So you provide the client secret and the client URL. That is the redirect URL, sorry. So when the token is generated from that client ID, it will send a request back to you with this redirect URL that, hey, this is your token. Now you can continue further. And you can see with redirect URL, with client secret, right? These are basically called, sorry, I went back. So this is called modifiers. You can have different modifiers to enhance the, your request. So you can use with authority, where you can define which tenant you would like to use to authenticate your users, right? Or you can specify with the tenant ID, with client ID, right, which is a registered app in that tenant, with redirect URL, where the token need to be sent. So many other options are there that you can attach. So you can make a pipeline. So if you go to the previous slide, you are making a pipeline that I'm creating a public client application builder object, which will forward the request to this client ID. But I can also specify that which tenant ID should belong to. Then I can also specify that which redirect URL I would like to use. So I can concatenate multiple requests or multiple parameters with my request, depending on my requirement. Now, before I get into the next last topic, I would like to show you a very interesting example, what I discussed with you, so that you can understand how it works, right? So, okay. So what I did is I went into my Azure Active Directory, and in the Active Directory, I went back to my, let me just go back here. Okay. In my Active Directory, I went into the registered app, and I have registered an app called with a name called .NET Core Graph Tutorial. And this graph tutorial has a client ID, which is EF71771C2, ends with 64F, right? So this application, if I click on it, it says that I am going to authenticate this user, right? I'm going to authenticate this user using the organization, right? So where it will authenticate a user from the current Active Directory and the partner's ID. You can see that accounts in my organization directory and multi-tenant means all the Azure directories that I've integrated with. So I'll authenticate it, and this is the redirect URL from where the request has been coming. I want to send the token back to that client, right? Okay. So let's see how I am using it. So please keep in mind this ID, right? So what I did is in my application, I created a console application which is not running in the cloud. It is running in on my laptop. I gave it a name called Graph Tutorial. Now I have downloaded the package for MSAL. That is this one. I use this Microsoft.identity.client, right? I use that, right? And then I want to use some graph APIs. I did that. So what code I'm writing? So what I want to access a graph API and the calendar, which I have, right, which I have a permission to work with. So I have created, first of all, a folder having a code which will going to generate a token for me, right? Authentication provider. So this device code auth provider class says that I'm implementing an interface, I authentication provider. So whenever you are creating an object of mine, I create an object of mine, you have to provide me which registered app you want to work with and what permissions you need as an array of string. Whatever permission you need, I will store it in my local variable, right? So this particular device code authentication provider class object will have the scope information, plus I am creating the public client application builder by saying public client application builder dot create app ID with authority means I want to authenticate my user from Azure and personal Microsoft account, right? And this request will be forwarded to that registered app ID. But where it is coming from? It is coming from the caller, right? Now, I would like to show you that in my main application, what I'm doing is I'm loading the app settings. So I have this setting here. You can see This is a secret.json file that I've created. So in this, I define the app ID, right, which is the same app ID of the registered app. And the permissions is user.read, semicolons, calendar.read. These are the two permissions that I need. So I am going to use this information. So in my program, when I load this setting, I am writing the logic at the bottom to check that whatever file I'm working with, right, it has app ID and app scope. Yes, I have an app ID and scope. I do have. Then I will return this configuration file here. Now, in this configuration file, what I'm doing is I'm saying that get me the app ID. So I get the app ID here. So just a second, let me scroll down. So I'm getting app ID and I got the scope, which is semicolon separated, but I say that no, I need an array. So I will split the values with the semicolons. So it will be an array. Now I created an object of that device code provider. So I created an object of this class. And when I'm creating an object of this class, I'm providing the app ID and the scope as an array of string. So my authentication provider is created. Now I would like to show you that I want to access the Graph API and I want to get my profile. So I created a class called Graph Helper where I am creating an object of Graph Client and provide the auth provider. So when somebody will going to call initialize method of this class, they have to provide that token. And that token is added with my graph client. So if my graph client will take any request to graph API, that token will be sent along with it. And then I am asking my graph client to call a method called me, means get me the current profile, right? It will give me the current profile. So when I will call this method, it will going to call the current profile from the graph client. As well as if somebody will going to call get event async method, then in that case, I'm asking my graph client to connect to my profile and get all the events that are associated with me. But every event can have many information, but I just want to return subject, organizer, start and end date. That's what I would like to return. Now, in my program file, when I created a device code provider, I get the token with me. Now, I just want to show you, I called my graph helper.initialize method and provide that token. So now my graph client is aware about that which provider I'm using. This is generated. Graph client is generated. Now I'm asking my graph client, right? I'm asking the graph client to call my profile. So graph helper has a get me async method. So get me async method, this one. So I'm calling that method. And when I call this method, I'm getting the result, which is a user profile. I'm showing the display name of the user, as well as I'm going to give a choices to the user. Hey, what do you want? I say, show me the list calendar event. So when he pressed 2, then what I'm doing it, I am actually calling the list calendar events. That is my method. And I'm calling graph helper.get event async. Means I am calling this method. And in that, I'm asking my graph client to get me all my events, right? But only these information for every event. And I'm displaying this information because I get multiple events. I'm getting one event at a time. I'm showing subject, right? Organizers, email ID, email address.name, start name, and end name. This is what I did. And it is an example of device code authentication, right? So how this device code works, let me show you. So when I run this application, it will give me a URL that I need to open in a browser. So it will run my application. Just waiting. Okay, so it says that this is the URL that you have to open in a browser. So I went into another browser. So I pasted there, and then it will ask me, once it is opening that login page, device login page, then it will going to ask me to provide a code. You can just logging in. It says that enter the code. Which code? That code is also given back to me here. So I will copy this code and then I paste it here. Now my request will go to the registered app. So registered app says that provide me your credentials. So I am using the credentials here. So password, hopefully this is the right password. Okay, it is asking me to verify it on the phone. So I'm expecting to get a message. Yes, I got a message. 290943. I verified it. So now you can see what it is saying. Are you trying to sign into your .NET Core Graph tutorial, that registered app? I say yes. So once I click, it says that you have signed in. Now I'll go back to my application and it will show me the current display name because it has called the graph should give me my name. It says that list calendar events, press 2. So I press 2. It will give me all the events that I am having here, right? Like my flight details, my meetings, everything. So this is an example of the the way by which I'm using Microsoft Authentication Library to talk to Identity Platform version 2. So that's the example that will clear all the doubts that you have in the theoretical part. Now we are moving to the last bit of it, implement shared access signature. Now, what it is all about. Now I'll go to the storage accounts, or I'll go to home and I'll find the storage account. So this is the storage account that we created before. So this is on day 2. So storage account says that, right, I have containers, I have file shares that you can mount it with containers, you have queues, you have tables. Now, how to access them? If you want to access this, right, as a programmer, so you need access keys, right? And when you click on the access keys, you will see there are 2 keys and connection strings associated with that. This is the access key and in a connection string. So in this connection string, I am using that access key here. I'm using this access key in this, and this access key I'm using in this connection string. Both of them having the same permissions. Because sometimes if it get compromised, I want to rotate it. In the meanwhile, I can give you the second one so that your task will not hamper, right? But the problem with this, if I give you this access key or this connection string, you become an owner of it. You can do anything with this connection string, right? It is a master key or master connection string. So you can delete a table, create a table, containers, file share, you can delete a storage account, whatever you want, you can do that. But no, I don't want that. I only want to use it for management purpose. But for a normal day-to-day activity, I don't want you to use it. I want that when a user logs in, he just want to play with tables. So he should get its own credentials and token that only allow him to work with tables, queues, and so. So in that case, we will go with the concept of shared access signature. So shared access signature is a temporary token. It will help you out to generate a temporary token with the limited permissions, right? So here I say that I want to generate a shared access signature which will only allow you to work with blob and the queues, means binary large objects and the tables. Only this, right? Service, containers, and objects inside. Okay, what do you want? I want that user can only read. They cannot make any changes. Right. Okay. They can filter it, they can read it, they can get all items, but they cannot write, they cannot delete if they use this connection. And this token is valid from this time to this time. I can add another filter condition that if request is coming with that token which I will with the token which I will give it to you, or with the connection string which I will give it to you. If it is coming from that IP range, then only I will trust it. But I'm not adding this. So anyone who will get that connection string, right, they can work with it. Now, request can come from HTTPS or both. I say any request. Now you can see that I'm generating the connection string based on the key one, access key one. So now this key is there. So if I give you this connection string, so you will prove your authenticity and you will get a token that is valid for this duration. And you can only work with blobs and tables with read and list permission. And then token will be expiring it after this. So even if this token get compromised, right? So I know that you can only read and list this data. So it is not that problematic thing. And after this much time, it will going to expire. right? So that is the beauty of it. So that is a shared access signature. Now I can generate this shared access signature programmatically as well. It is not only like that I have to generate it here. No, I can programmatically generate the shared access signature, right? Every time user logs in, I can generate a new one and give him a permission to work with the resources. Now the problem here is, if I have generated the shared access signature at a storage account level from here, so said that you can access blobs and tables with these permissions. Means in this blob, I can have 5 containers. I have 10 tables. So a user can work with all containers and tables with the same permissions. But sometimes it happens that if I go to the container, I don't want that this container does not want the same permissions. It wants its own permissions. I want that when user connects to this container, he can work with different permissions, not by this shared access signature. So at a container level also, I can manage the permissions. So if I click on it, so you can see that I have the option to work with access policies or generate a shared access signature. So first of all, shared access signature. Now shared access signature is generated at a container level as well or table level as well. So I click on that. So maybe if you are accessing this container, specifically this container, I can say that I would like to give you read and delete and list permissions. I have added one more permission, right? And then this token is valid from this time to this time, exactly the same. And I say generate SAS token and the URL. So this is the token that is generated, which you can add it at the end of your URL, right? This is the URL. So if I copy this URL and I put it here, so you will see here that this URL says that I'm talking about images because it is a blob. So it is a container. So this is the blob service which is talking to this container. So I am giving a special permissions of read, delete, and list. And start time is this, and end time is this. Right. Now, if the request is coming from HTTPS, then only it is allowed. Then this is a version number and source. C is container. Means I want to give this permission on this, which is a container. And whatever token is there is signed with this signature. Means it cannot be hacked. Right. So when this request comes from the customer to cloud to the storage account says that, oh, your request want to access this. Let me check. Yes, this permission is there. Okay, this token is valid for this. Let me check it this with my list. Yes, it matches. So I'll give you the token and work with it. So that is the shared access signature. You can define the shared access signature at a storage account level or at a container level. But what about the files? Right. If you have any file here, so if you click here, right. So if you click here, you can see we have a shared access signature at a file level also. So we can grant permission to the lower level at a file level as well. So each file can have its own shared access signature. So we can give different permissions at file level as well, right? But there is one problem with these shared access signatures, that every time I'm generating it in my URL, whenever I'm submitting my request, I have complete list of details, right? Which I have to send. So what I can do is I can also work with policies. So if I want to work with the policies, I have to go at a container level, right? I can't generate a policy, shared access policy at a file level. It is defined at a container level. So policy, it says that instead of generating the shared access signature, create a policy. So I'm creating a policy that is called shared access policy. I'm adding a policy, give it a name, policy 1. What permission you need? Exactly the same thing, read, delete, and list. From which time to which time? So let's say from today till tomorrow, define that, and then click OK. So my policy is added, right? Now, once policy is, sorry, I save this. And once policy is added, so what I can do now? I can see here, right? I can edit the policy or delete it. What I can do is I can select that and I can go to that shared access signature, instead of defining that, I can choose the policy. I say that I want to create a policy, use the policy, which will give me these permissions, and I can generate a SAS token. So this SAS token is automatically generated based on the policy. So I can copy it and you can paste it here. Right. Now, the difference is that instead of having the details about what special permissions you need, right, I'm defining the policy one. Right. So this policy one says that when your request comes to me, I will check this policy is there with me. Yes, this policy is with me. What permission it is, I'll check the permission and I'll give you the token with that permission. So that is what shared access policies are. Now I can go back to my file, right? And I can generate SAS token, and I can choose the policy here as well. So it means that I can create a policy at a container level. I can get 10 policies, and each file can choose its own policy. So at a file level, I can choose a policy to generate a shared access signature so that I can access that resource with the limited permissions for a limited time. So that's the beauty of shared access signature. So implement shared access signature. I told you what it is. Type of shared signatures: use user delegation SAS, service SAS, or account SAS. Means at a file level, at a container level, or service level like blob, or a account level. So 3 levels. Best practice: always use HTTPS. The most secure SAS is a user delegation. Means each request you can define the SAS token for files. Every file that you're trying to work with, for every container you're trying to work with it, you can have its own policy instead of defining it account level or a service level. You can set a expiration time for a small amount of time so that your token is automatically expired after that time. Even it get compromised, so it will not make much difference. And try to give limited permissions wherever applicable. And SAS is not always the correct solution, right? So we can use the policies or we can use the access keys. So I told you, whenever you are submitting a request, what does it mean? Whenever you create a SAS token, right, which is concatenated with your URL, so SP specify what permission you need. R, read permission, right? L, list, right? W for write, A for add, C for create. So you might get read, add, and delete, RAD. Start, the date and time when the token will be generated, when it will start and when it will end. What is the version of the storage API that you are working with? Source, B is a blob. You can see this is the image, which is a blob available in a container. So this policy is only applicable to the current file. And a signature, cryptographic signature, which is added at the end, which will tell that your request has not been tampered with. Now, you submit a request, right, for manipulating the storage account. So clients upload and download the data via front-end proxy service, which perform authentication. The front-end proxy service has an advantage of allowing validation of business rules, but for large amount of data or higher volume transaction. So we will not going to talk to the Azure, we'll talk to the service, and service will talk to the Azure. Now this service will define the permissions that it wants to work with. It wants to use shared access signature or not. So whenever your application wants to communicate with the storage account, you need to prove your authenticity. So you can send a request to the Azure storage and say, hey, I want to get a shared access signature. So you will pass this information in your request, this or this. So whenever you are passing this request, it will going to validate that request and give you the token back. And with that token, you can access your Azure storage resources. Stored access policies, as I discussed with you. Shared access signature basically is a way where you are defining every time that what permissions you need, right? Every time you have to define a permission, but it's better that you can define a policy at a container level and reuse that policy at a container level or at a file level. Same policy can be used and or shared at a container level or a file level. So it is easy because you are defining it once and using it multiple times. So as I was showing it to you that I have defined a policy at a container level. If I go here and I choose the access policies, so I have defined a policy here. I can add as many policies as I want. And then when I get into the files here, so the files, basically can decide which policy did you want to use. So when I connect to this, I would like to say, I want to generate a shared access signature, but I don't want to define the permissions because it is coming from the policy. And then I will generate a SAS. So it makes the life simpler because I defined the policy at permissions at one place and I'm just reusing them to generate my shared access signature. So that is the idea behind the policies. So this is an example how to work with that. So if you want to work with the policies, so you can say that I'm using a blob signed identifier object, and there you define the policy name and access policies that you need. So it will expire after 1 hour and permission is read and write. So it will going to create a new policy with these permissions and it is valid for 1 hour. Now, when you want to create a policy with CLI, this is with code, with SDK, this is with CLI. So you can say AZ storage container policy create. You define the name of the policy, the container with which the policy has to be associated, start time, expiry time, what permission you need, right? This container is available in which storage account and what key is used to generate that. So you define the policy with CLI as well. So there are multiple ways of generating the policies. So on that note, I am done with the concept of talking about the three things, right? I talked about the first scenario that I deal with is just let's go back and talk about it. So I talked about the first topic that is implement containerized solutions. I told you what is containerization, why we need it, what are the benefits of it, right? How to create a container instance, and what is the Docker file, what is an image inside, what is Azure Container Registry, what is the flow of working with containerization, right? So just a recap. So we talk about this flow. So first of all, create an application. In the root folder of an application, create a Docker file, which contain all the instructions that will help you to run your application in a container. But we cannot use this Docker file directly. So we need to convert this Docker file into a container image. So we will use a Docker command, or we can use ACR commands to convert that into a container image and then push that container image into the container registry. Once my image is into the container registry, it means that it is available to the users of my organization so that people can connect to it, get the container image, and create container instances based on that. So that is the idea behind it. If you want to create a one container at a time, one or two containers, then you can easily use container instance service, container instance service. You can use it, container instances, or you can use web app, or you can use Azure functions. There are so many services which are integrated with container registry. But if you want to maintain hundreds of containers based on the same image, right? Reason behind it, because you want to auto scale the capabilities, you want to go with load balancing, high availability. So you cannot do it manually. So in that case, you need an orchestration platform like Kubernetes or Docker Swarm or Helm charts. Different options are there.